This is what's called a YouTube manometer. It's in the shape of a U. There's actually a tube here which did not print on my printer, not all the entire tube anyway. And the way this works is there's a gas contained in this space or this volume right here, and the gas has a pressure of 615 millimeters of mercury. The atmosphere is pushing down, and this is open to the atmosphere.
Sorry, Professor, what question is this?
This is 03-07.
Thank you.
Yep. And okay, so the atmospheric pressure is pushing down here, and there's a height difference, and the substance down here is mercury, which is one of the few liquids, Hg liquid. The question is, if height equals 65 millimeters, what is the atmospheric pressure, P atm, or P sub atm, the atmospheric pressure? So the things we have to know about this is, first off, the pressure of the atmosphere is greater than the pressure of the gas. And we know that because the pressure of the atmosphere is able to push the mercury farther in the tube or lower in the tube. If the pressures were exactly the same, then the levels would be exactly the same for the height of the mercury. The fact that the atmosphere pushes it more means that the pressure of the atmosphere is higher. From there, what I like to do is, so the pressure of the atmosphere is going to be equal to the pressure of the gas plus the height of mercury. And height of mercury is nice because our pressures are in millimeters of mercury. So we know that the gas pressure is 615 millimeters of mercury. And the height of the mercury is 65 millimeters, and of course those are millimeters of mercury. And so we can plug in and see that we get 680 millimeters of mercury for this. Now, the thing that I'd also like to go over is what happens if the other case is true. And so let me move this up a little bit. What if in a U-tube let me show that. Is that all? Yep. The mercury was lower for the gas tube, or in contact with the gas, but otherwise it's exactly the same setup. In this case, we would say that the pressure of the atmosphere is less than the pressure of the gas. And the equal statement that we can say is that the pressure of the gas is equal to the pressure of the atmosphere plus the height. And the height of the mercury in this case. So, and I just want to go over that specifically because this is my process for solving these, is first off identify which one's bigger, because whichever one's bigger, you add the height to the other one. And again, there's lots of processes for doing this. What I would suggest is after you solve this, you go back and you're like, oh, does my answer make sense? So the pressure up here for the atmosphere is a bigger number, and that's what I expected to get for this problem. Any questions about that?